All right, after talking about the sets, I hope you understand exactly what that means, especially about the elements of the sets. And I mean, every set has how many like elements, like for A has like 4, for B has the same thing, C is 2. Now we can talk a little bit about probability. But before talk about probability, I wanna like first try to define it. But before the definition, I will need you to understand what's the importance of this, what we're doing right now. I mean, it's probability. What is the importance of it? Let me give you an example. If, for example, I will ask you guys like to choose a number between 2 and 12, because we're gonna roll like 2 die. I'm sorry, I have only 1 dice. Let's imagine we're gonna roll like 2 dice, and I'm asking you to choose a number between 1 and 12. I mean, sorry, between 2 and 12, because 1 you cannot, is impossible. It's impossible for events. So what is the number we're going to choose? So I did the test in the class before, and a lot of students, they would start to say, I choose like 5, the other one is 2, the other one 3. And when I'm asking them, they always said, because it's my date of birth, or because it's like, it's just like this, I like 7, everybody like say different ways. We need to understand what is the importance of math on those things. So math is going to help us to make a decision, by the way. So the decision is, I will say, guys, yes, is a chance, because for probability is every experiment in activity involving chance. But we need to know that we can at least know what is the chance to have like 2. What is the chance to have the chance to have 2, for example, is only 1 and 1. It means you need to roll only, you need to get like only 1 and 1 is only 1 chance to have this situation. But let's check, for example, the number. We say the number 6, the number 7, and the number 8. So if I am the person I'm going to choose, I would say, listen, it's better to choose 6 or 7 or 8. Why? Because 6 you can get it with different situation. So I can have 6 with ruling 4 and 2. Oh, I got only 1 right here. 4 and 2. And I can get 6 with ruling 3 and 3. And I can get 6 with ruling 5 and 1. Look how many chances I can have. So is 4 and 2 give me 6. 3 and 3 give me 6. And 5 and 1 give me 6. But for 2, you have only 1 situation, which is 1 and 1. That's the only one you can give you 2, by the way. For 7, same thing. Let's talk about 7. 7, for example, you have 4 and 3, you have 5 and 2, and you have 6 and 1. Same thing. And for 8, it's basically the same thing. 4 and 4, and 5 and 3, and 6 and 2. As you can see it. But for example, if I said, no, I want to choose 12. So in order to have 12, you need to have 2 times 6. That's the only situation. So this is why in probability it can help you a little bit to make the decision. But of course, maybe the person gonna like pick the 12 is gonna be right, but this is a chance, right? We're trying just to give you what is the chance is more likely to have 6, 7, 8, because for 6 is 3 situations. So maybe you're gonna have 4 and 2, you're good. 2 and 4, you're good. 3 and 3 is good. 5 and 1, and 1 and 5 is good. So this is better to choose, for example, those 3. So if I want to make a decision, probability will help me a little bit to make the decision, by the way. So this is why math is here, is to help us to make decisions in our life. All right, so let's talk now about probability, by the way. So the first thing I want you to understand is how we can calculate probability. So the probability is, let me grab this one right here. All right, so probability of A, of any event of A, is the number of outcomes in the event over the number of outcomes in the sample space. What is sample space? Sample space is a universal set, if you want, universal set, where you're doing your test. So let me see, for example, for the other problem that we did before. Let's check this one, and at the same time try to apply what we just learned right here. So the probability of any event is number of outcomes in the event over number of outcomes in the sample space. I'm sorry. So let's check, for example, here. For the event A, we have 2, 3, 5, 7. How many elements? It's 4. So we have the elements. You have to count the elements, right? So how many elements right here is 4. And for the universal set, is 9. So we have 9 elements, 4 elements. So in this case, we have 4 over 9. I know, guys, you will understand better with another example. So I have another example for you, so to understand better what I'm talking about. Let's keep this in our mind and to understand what that means. So every time we need to know how many the events itself, right, and the simple space. All right. So let's try to understand with this little example right here. The example says you roll a number cube, which is this one. The even A is rolling a prime numbers, right? Is rolling prime numbers. And the even B is rolling an even number. So he asks you, calculate what is the probability of A to have A. What is this probability to have A? Is it very easy. So first thing to do is what? Is to find what is how many numbers, how many elements in every set. So let's talk about the set A. How many elements in the set A? So what is the set A, by the way? Start first to know what is the set A. A set is what? A is is rolling a prime number, so all prime numbers. So before to talk about set A, it's better, guys, to start with we call it the simple space or universal set, right? Simple space. So what is a simple space right here? Simple space is all possible outcomes. What is all possible outcomes? It can be 1, it can be 2, it can be 3, it can be 4, it can be 5, it can be 6. It cannot be another thing. So S is what? All those numbers. 1, 2, 3, 4, 5, 6. Right? So how many elements, by the way, is 6 elements. So n of S are 6. Let's try with another thing now, which is, how about A? A is what? We just say it is rolling a prime number. So the prime number, what is the prime number in this case? So it can be, what is those times? 2, 3, and 5, right? 2, 3, and 5. That's it. So 2, 3, and 5. How many elements right here? So n of A is how many elements? It's 3, right? So the probability now is very easy. So the probability of A, let me just write it good right here. So the probability of A is what? Is n of A, right, over n of S. Is all events of A, the elements of A, over all possible outcome. Possible outcome is here is only 6. That's only 6 situations we can have. 1 or 2 or 3 or 4 or 5 or 6. We cannot have something else. So n of A, how many elements of A? Is 3. So we're gonna say is 3. And n of 6, how many elements of the simple space? We call it simple space. It means all possible outcomes. Or it can be when we roll those dice. Is 6. So 3 over 6. Well, when we simplify, it's going to be 1 over 2, right? So in order, we have only, if you want, 50% or the chance to have 2, 3, or 5. And he said the even B right here, the even B is rolling an even number. B is rolling an even number. So what is for B? Let's try to find what is probability of B, right? What's probability of B? Even number. So for the probability of B, so we need to find what is the set of B. So what is the set of B? Is 2, 4, it's even, right? Set even number is 2, 4, and 6. That's it. And it's basically the same probability of of A, right? So what is the probability of B? Is the numbers of B. So because n of B right here is the same thing, is 3 elements, 1, 2, 3, so it's 3. And probability of B is what? Is 3, which is n of B, let me write it down again, n of B over n of S. S is all possible outcome, just say. So n of B is 3, and n of S is 6, and it's the same thing, 1 over 2, right? So let's try to use a little bit. Let me just get another paper and make you understand when we talk about. How about now if they ask you what is the probability of? Okay, I'm good. What is the probability of A union B? A union B. What is the probability of A union B? So the first thing to do is what? Is to find out what is A union B first. So probability of A union B, what is A union B set? A union B is what? So let's check. What is A? Is 2, 3, 5. And what is B? Is 2, 4, 6. So is 2, 3, 4, right? 5, and 6. Yes or no? So how many elements right here? 1, 2, 3, 4, 5. So we have 5 elements. So let's check what is probability now of A union of B. So the n of A union B, how many is? 5, right? So probability A union B is always the numbers of elements of A union of B over the number of elements of the simple space. So how many numbers was there here? Is 5 over 6. Here we go. And how about if they ask you what is the probability of A intersect B? So A intersect B is what? A intersect B, so the first thing we need to find out is A intersect B. So A intersect B set is what? Can we check what is that? Okay, what is A? A is this one. Let's keep this on our eyes. And what is B? B is this one. So the intersection is what here? It's only 1, right? One number is only 2. They have the same number, which is 2. So 2 is right here. 2 is in this set 2. So A intersect, this is intersect, right? Intersect B is only 2. So how many elements? Only one element. One element. So the probability now of A intersect of B is the numbers of the elements A intercept, B over the numbers of elements of simple space. So we're gonna have how many here is 1, and this is we know is 6. So it's 1 over 6. All right. So the last one is a very important one when we talk about complement even. So the complement even. How about if they ask you what is the probability of the complement even of A? We write it like this, right? If you remember. So is A the complement even of A? So what is the complement? This first thing we need to find out is what is the complement even of A? The first thing is to check is the elements of A. So the elements of A is A equals to what? Is 2, 3, 5. Prime numbers. So what is the complement even of A? So we said the complement even of A is all those elements that are not in A, but they have to complete like till the how we call it, the simple space. I'm sorry. So what is the simple space elements? Simple space elements is S equals to what? Is 1, 2, 3, 4, 5, and 6. Right? So let's check together. So we have this element exists, 3 exists, and 5 exists. So the complement of A are those numbers 1, 4, and 6. So are 1, 4, and 6. How many numbers so far? Is 1, 2, 3. So it's 3 numbers. I mean, if I want to write it down, I'm sorry, I will write it N. Oh my God. Okay, N of A, complement of A, is 3 elements. So if I want to find the probability of it, so I'm messing a little bit up here. I'm checking at the same time as my video. All right, that's good. All right, so the complement of the event A, so the probability of it equals to what? Is N of A of the complement of A over N of S. And what, I'm sorry, I'm messing a little bit up, but I think you understand what I'm doing. So how many elements? We just said is 3, right? So 3 over, what is, how many elements of simple space? We said is 6. And this you can simplify and it became 1 over 2. So we divide by 3 and we divide by 3. So this is another example to tell you that if we understand the sets and how we can like manage the sets and understand really good the sets, probability is going to be a little bit more easier for us.